In this video we are going to be looking at velocity time graphs. If you haven't already looked at the distance time graph video, please do, and this is the next part. So we are focusing on velocity time graphs with straight lines only. Further on in the course we will be dealing with velocity time graphs with curves. So what is a velocity time graph? It is a graph that shows how velocity changes with time. Now there are a few key terms that we need to know. The first one is velocity. What is velocity? So it's a measure of how fast something moves, but direction is important. So it's the measure of how fast something moves in a particular direction. So if I have two objects, one is moving at 8 meters per second and another is moving at -8 meters per second, they're traveling at the same speed because they have the same numerical value, but one is going in the positive direction, one is going in the negative, so it shows they're going in different directions. Now the other key term we need to know about is acceleration. Acceleration is the rate of change of velocity, and in simpler terms that's basically the rate at which an object is getting faster, so speeding up, or slowing down. Now the formula for acceleration is change in velocity over change in time. And what you'll find as we go through this, that you'll recognise that's actually finding the gradient, but we'll look at that later on. Now the units for acceleration combines the units for velocity, so meters, and time, so it's meters per second squared. So here is a velocity time graph, and it looks very similar to a distance time graph. However, let's have a look at this first line. This shows constant acceleration, so the object is speeding up at a constant rate. Now this part of the line, the flat line, the object is travelling at a constant speed, so that's a constant velocity. It's not getting faster, it's not getting slower. The final part of this velocity time graph shows a constant deceleration. Now the steeper the line, the greater the acceleration of the object, and that is still the same from distance time graphs. But instead these lines are showing an object speeding up or slowing down. The horizontal line on a distance time graph shows an object is not moving, but on a velocity time graph it shows it is travelling at a constant speed, so it's no longer going up or down in speed. So like I said at the beginning, there's focus on no curves, it's all straight lines for this video. And for this section of the syllabus we only need to focus on straight lines. So to find the acceleration, like we were talking about earlier, you need to find the gradient. So if I again have a look at this question. So the graph shows the velocity of a car during a journey. Calculate the acceleration of the car at 4.5 seconds into the journey. So if I do a little dotted line at 4.5 and hit my graph, it's at a straight line. So the object is travelling at a constant speed, there's no acceleration. Okay, it's not getting faster, it's not getting slower, it's a straight line, so it's 0 meters per second squared. Part B is 10 seconds into the journey. Now I've done a second dotted line there because at the start of that slope, that's where the slope starts to go down, and it ends at 11. So I'm basically looking for the gradient. Remember, the acceleration is the change in velocity over time, or the rise over the run. So looking at the height of that sort of triangle I've made, the height is 12.5, and then if you go across, we're going to look at the time between 6 and 11 seconds. So let's work out the change in velocity, let's write down the change in time, and then we'll be able to divide them to find the acceleration. So the change in velocity was 12.5, the time is between 6 and 11 seconds, so the time is 5, so 5 seconds, and the acceleration is therefore going to be 12.5 divided by 5. So it's essentially the gradient of that slope between 6 and 11. Now the reason why I didn't go just from 6 to 10 is because we could have, we were just looking at the gradient of this line from one point to the other, and I focused on the start of the line and the end. Now remember, because it's going down the line, it's a deceleration, so you need to show that it's a negative, so it's going to be negative 12.5. Now on velocity time graphs we can also calculate the distance. Now to find the distance, it's basically to find the area under the graph. Now sometimes they can ask you for specific parts of the journey, but here is an area recap. You need to be able to use rectangles, triangles and trapeziums. So the area of a rectangle is just the base times the height. The area of a triangle is the base times the height and then halved, because remember a triangle is half of a rectangle. And finally the trapezium, which is one students tend to forget most often, is a plus b halved and then times it by the height. So a is the top length, b is the bottom, and the height is the perpendicular height. So if we look at this next example, and it shows you how to find the distance. So the diagram shows the velocity of a train for the first 60 seconds of a journey. Calculate the total distance travelled during this part of the journey. Now I could, because I know it's going all the way to 60 seconds, do a dotted line at the end and produce a trapezium. Now if you find that you've forgotten how to find the area of a trapezium, you can also divide the shape into two bits, so a triangle and a rectangle. I'm going to label these two A and B, just so I can sort of split up my working out basically. So let's find the area of A first. It's a triangle, so it's half the base times the height. The base is 30, the height is 25. So my area of A is 375. B is a rectangle, so it's just base times height, so that's 30 times 25. So to find the total area, I'm just going to add 375 and 750. And that's it. So to find the acceleration, we find the gradient. To find the distance, we find the area under the graph. And that's it.